Assalamu alaikum YouTubers. Welcome back to SLK Tours. Here in this section, we'll be just learning in detail the estimation of steel just for a triangular slab. Actually, a few friends just demand this guy from me, right? In the last lecture. That's why I'm making this lecture today about this triangular slab. Actually, we have just 6 type of triangles. Just stop the video over here and study this table in detail. I'm not discussing this guy in detail because this is just time consuming, right? I'll just take this one, a right angle triangle, right? Because the right angle triangle is quite simple and always used, right? And this is most popular triangle. In this example, we are given a triangle that has just length equals 20 feet and the breadth is just 10 feet. And we are demanded to calculate steel just in kg. Yes, I like this word, in kg. And the slab is already given, right? We are also informed to take the steel in both directions same, which is just number 4 bar at the rate of 12 inch center to center. And of course, we can just ignore concrete cover over here. So I think all data is given, right? And nothing is complicated over here. So I'll come straight into solution. But before starting the solution, let me show you how the steel must be distributed in this triangular slab. Just look at over here. This guy. Here we can also place just a steel bar over here. And in this direction as well, right? And this is going and so on. Also, we can just place or distribute steel in another direction like this one. I'll just first calculate this directional steel. Then I'll come over here to another side, right? So let me just do it. I'll first calculate length of this first bar. Let me call this is L1, right? And this is just white over here. You can just see at the base of this triangular slab. But what is just the length of bar 1 or what is just L1, right? Of course, you can clearly see it is just the length of this triangle, right, which is just 20 feet. So the length of bar 1 is just 20 feet. I can just say L1 is just 20 feet because you can clearly see it, right? It's not much complicated. Now what about L2? Yeah, this is just really little challenging over here, right? And of course the center to center distance between these two guys is just 12 inches, right? And the bar is number 4. How can I calculate L2? Just look at over here. If I draw a nice perpendicular line over here, then you can clearly see the L2 is just the portion of L1 over here. It means I just need to subtract this little guy from L1 so I can just find L2. Does it make sense? But how can I find this little guy? Let me just draw this small triangle over here for better visualization, right? And I'll call the base is X, which I want to calculate this guy over here. And of course the height or breadth of this guy is just 1 feet or 12 inches, right? Because this is just the center to center distance between these two bars. And this is of course given over here, right? And just look at over here. Now the triangle is not solvable because we have only one thing. It means we have only one side. We need another component, right? Just look at over here. This is just alpha, right, in angle. And of course the angle in this small triangle is just equal to the angle in this large or bigger wide triangle. It means I can find this alpha using tangent theta, right, or tangent alpha, which is of course equal to this 10 over 12, right, or perpendicular over base. Of course, you can find alpha from this guy when you turn tangent to another side. It means tangent inverse of these two guys. when you just divide 10 by 20, you can get 0.5. It means tangent inverse of 0.5 is just 26.565 degree. It means we got it, right? Now we can just find this x using tangent of theta again. Just look at over here. Tangent of this angle is just perpendicular or base. It means perpendicular is just 1 and the base is x, which we need over here, right? And now just look at over here, just do little cross multiplication, right? So you can get x equals 1 over tangent of theta, right? And do little mathematics with this guy using your calculator. You can get x equals 2 feet. It means this little guy is just 2 feet over here. Now what if I just subtract this 2 from L1, then I can get of course L2, right? And this is quite simple. So L2 is just L1 negative this small thing, which is 2. So you can get L1 is just 20 negative 2, you can get 18 feet, right? So the length of bar 2 is just 18 feet. What do you say about L3? This is bar 3, right? It is just the same thing. We'll just subtract 2 feet from this L2. We can get L3, right? So L3 equals L2 negative this little guy, just making over here. This is just 2. This must be 18 negative 2 equals 16. What about L4? Of course, it's the same thing we are just doing, right? So L4 is just L3 negative 2. Plug in again, you can get L4 equals L3 is just 16, negative 2 equals 14. What about L5? Of course, we can just subtract 2 from L4, right? So L4 negative 2 equals 12. Yes, this is quite simple, right? It's amazing, I think. And this is quite simple. Now, and so on, you can do these guys, right, by yourself. Just subtract 2 from each bar, you can get the next bar, right? Like I'm just making this guy L6, this is just L5 negative 2, right? L5 is just 12, negative 2, you can get 10. And L7 is just L6 negative 2, right? And L8 is just L7 negative 2, right? L7 is just 8, negative 2 equals 6. L9, it is just 6 negative 2. And L10, it is just 4 negative 2, right? What about L11? What do you say about L11? L11 will be just L10 negative 2, but L10 is just 2 and 2 negative 2 is just 0. It means we don't have just L11, right? So when you add these guys together, you can get the total length of bar equals 110 feet. Actually, if you are just a CAD user, you can do these guys so quickly, right? Let me just jump a little time and we are just gonna take a little time over here. I've just drawn this guy over here, 20 and 10. Let me take just multiple offsets from this guy, and the offset value is just of course 1 feet, right? And I'm taking these guys just like in this palm. What do you say? Does it make sense? Yeah, of course. And let me just trim these guys for a little time. And now from dimension, I can use quick dimension. The L1 is of course just 20 feet, right? And this is 18, yes. Of course, this is 16. This guy is just 14. 12, 10, 8, 6, 4, and of course 2. And there is nothing left over here, right? So you can use your AutoCAD, right, for this purpose too. I'll come back into my presentation over here. This one, yes. Now I have the total length of these bars. Of course, I can calculate the width using the same formula I always use, which is just, of course, the weight of bar must be d square divided by 52.9. This will give me weight in kg per feet. When I just multiply L with this guy, I can get the total weight of this all bars, right? These all bars. So plug and chug in, you must get the weight of bar equals, the diameter must be in Sudha, right? And we are informed to take number 4 bars. So 4 square divided by this guy times the length is given, which is 110. When you just calculate this guy, this little guy, you can get 0.302 times the length. Of course, you can get 33.2 kg. And this is quite simple, I think, right? So just look at over here. This was just our first approach in this direction. Now just do this direction by yourself, right? This is just the same method we did, right? And this is quite simple. I think we are just done. Yes, it's good. So thank you for watching. See you next time. And what? Nothing. Wassalam.